Alright friends, welcome back. In this video I'd like to go ahead and cover the next section of chapter 6, which is going to be 6.2, and in this video specifically we're going to cover the method of elimination to solve a system of equations. So let's get started. So in general, the elimination method involves this idea right here. So your goal is going to be to take both equations and to get a pair of variables, so either a pair of x's or a pair of y's, maybe with the same coefficients or different coefficients. We need them to be eliminated or cancel out. And so the way that we're going to get that done is by making sure that one of them has a positive sign, the other one has a negative sign. So that way when we add the two equations, we're going to go ahead and notice that those terms cancel out, just leaving us with the other variable in the problem, okay? And so here's a little bit of a demonstration on how that process would work. You'll notice that in these two equations, I have my x term, and they both have a coefficient of 3. However, one of them has a coefficient of positive 3, while the other has a coefficient of negative 3. So that way, when we go ahead and add these two equations, you'll notice that I drew a little bit of a graphic organizer to make sure that everything was nice and lined up. You notice if I were to add the two equations, I would be adding my x terms and then my y terms and then my constants. My x terms would just fall out of the problem and get eliminated, hence the name of the method, right? And then we would just go ahead and do that same thing to all of the different other columns here. So the signs in front of the numbers, I want you guys to go ahead and read those as the sign on the number. So for example, whenever you're reading this system right here, we're going to read this as positive 5 plus negative 2. I think that's just going to give you an easier time trying to make sense out of what your results are going to be in each column. And you notice that this is going to whittle it down to just a single variable. Y is going to be equal to 4, okay? And what we're now going to do is we're going to take one of our original equations and plug that number back in for y and get the corresponding x, which you can see the work for there on the right. And we're always going to go ahead and write our solution as an ordered pair, just like in the last video, okay? So let's go ahead and demonstrate that process here by working out this example here. So example 1, it just says solve the system of linear equations, and so we have this system right here. You might notice if you look at the coefficients on your y's that it's already ready to go. Again, you don't have to do this, but this is something that I have always done whenever I do elimination method. That's something that helps me remember that I need to keep everything nice and lined up. And because the coefficients on my y's are positive 2 and negative 2, that tells me that I need to go ahead and add these two equations together. So I'm just going to think about that as adding each column. So 3x plus 5x, of course, makes 8x. And then the y column completely cancels out because I have 2 plus negative 2, and that makes 0. And then finally, in my column of constants here, I have 2 plus 6, and of course that makes 8. And we whittle the equation down to this right here. 8 times x is equal to 8. And of course, we could figure out what that is by either doing that mentally, it'll be 1, or you could do it algebraically by showing the work here. Divide both sides by 8, and you indeed get an x value of 1, okay? Now, that's not our final answer because remember that in a system, when you solve it, we need to come up with a value for both x and y. And so what we're now going to do is we're going to pick one of our original equations. We're going to plug our x value back in, and we're going to solve for y. In terms of which equation you need to go back and pick, it does not matter. You could pick either one. I typically try to pick the equation without any minus signs in it or negatives. I also try to shoot for picking the equation that has smaller numbers in it. So for that reason, I'm just going to go ahead and pick this first equation, the one that says 3x plus 2y is equal to 2. And I'm just going to go ahead and plug in my value for x. So x is equal to 1, so I'm just going to plug that in here. And that makes it so that the only unknown in this whole equation is simply just y. And so 3 times 1 is just 3. So I'm just going to go ahead and do that step here. By subtracting 3 from both sides, I get 2y is going to be equal to negative 1. And then finally, of course, dividing both sides by 2, I'm going to get y is going to be equal to a negative 1/2. Okay, and so once you have your value for both coordinates here, we're going to go ahead and write that as an ordered pair by saying 1, comma, negative 1/2, and then that completes the problem right there, okay? So again, when you solve a system by elimination, it's super easy to do if it's already ready to go for you. What you may find is that you need to go through and multiply one or both of your equations times some number to get the coefficients in one of your columns to match up. Okay, and so that, for example, will happen here in example 2, which is, you'll notice something I already went ahead and worked out here for you just for sake of time in the video. I encourage you to go ahead and pause the screen and read through what we've done here. You'll notice that for the most part, it's the exact same process as we've always done here, but you'll notice that there's an additional step right here of multiplying this equation times 3, okay? The reason that we're, of course, doing that is because now if you look at your y column and add those together, we have some coefficients that match up here for us, and so that is going to eliminate that y column, hence the name of the method, elimination, okay? So go ahead and pause the screen, read through the rest of that one, and then unpause, and we'll go ahead and take care of the next one. All right, so this is basically just a little bit of a way to kind of summarize all the different things you need to keep in mind whenever you're solving by elimination. So you may need to go ahead and multiply all the terms of an equation, or maybe all the terms of both equations, by some number to get some coefficients to match up. And then after that, we're either going to add or subtract, depending on what our coefficients look like in the problem, to eliminate one of our columns and then solve for one of the variables. Once you get that solved for, you're going to plug it back into one of your original equations and then get the other variable. Okay, so let's demonstrate that process here by taking a look at example number 3. All right, so we have this system, and one of the things that always kind of catches my eye is anytime you have a variable with a coefficient of 1, okay, like this y does right here in the second equation. It's really easy to go ahead and get that coefficient to become a 5, because that just means we're just going to need to multiply everything in the second equation times the value of 5, okay? We're going to leave that first equation alone because it already has the coefficient that we wanted there, and so we're just going to go ahead and write that equation over again. There we go. And then when we multiply the second equation times 5 times all the terms, we get 10x plus 5y is going to be equal to positive 45. Now, you might have had a previous teacher in past years in your previous algebra courses that have told you to multiply everything times negative 5 so that you know you always have to add the equations, but I want to show you here that that's not really the necessary case here, right? If you go ahead and multiply everything by positive 5, all that's going to mean is that you're just going to need to subtract the two equations in order to eliminate that y column, okay? And so let's go ahead and do that here. So 3 minus 10, of course, is going to give us negative 7, and that is going to be equal to 10 minus 45, which of course gives us negative 35. And then if we go ahead and divide both sides by negative 7, we get our result here of x is equal to positive 5, okay? One of the reasons that one of your previous teachers might have taught it to you in that way is because you can see here that doing it the way that we just did it, we had to work with some negatives, which, you know, oftentimes there are some rules you have to keep in mind with negatives, but again, it bears repeating that you can do this using this method just fine. You don't always have to, you know, multiply and then add. You can multiply times something and then subtract. The goal is to eliminate one of the columns, so whatever's necessary for doing that is what you're going to have to do. And then finally, again, we need to solve for that other variable. I'm going to go back to the very original second equation there because it's got smaller numbers in it, no negatives. So I'm just going to start over with that. 2x plus y is equal to 9. I'm going to go ahead and plug in my x value of 5 here. And after doing a little bit of arithmetic there, 2 times 5, that's going to make 10. I'm just going to go ahead and quickly subtract that from both sides. Y is going to be equal to negative 1 here. So our final answer ends up being the ordered pair 5, negative 1. And that completes the problem. Okay, keep in mind that that is the pair of x and y's that if you were to plug them into both equations, it would make them true simultaneously. You notice that I did number 4 here for you, and again, I always encourage you to pause the screen here and make sure that you read through this, but you'll notice that in this example, we had to multiply both equations times some number in order to get those coefficients to match up. So you'll notice that I went ahead and just picked my coefficients on my x values. You could have totally done this problem by multiplying both equations times something that would get the coefficients of your y's to match up. That would have been completely legit. You would have gotten the same answer, but again, it's just kind of up to you whichever coefficients you want to get to match up. But this would be how the problem works out. I'm going to go ahead and move on here, and we're going to talk about some problems where you actually have to apply a system and solve a word problem, basically, right? So some things to keep in mind, okay? So when you read through your word problem, you want to kind of ask yourself some questions. So first of all, does the problem involve more than one unknown quantity, right? So we may go through and ask about the number of calories to a cheeseburger and the number of calories to a small order of fries or something like that, right? Those are two things that we don't know. That's kind of a dead giveaway that you're going to need to solve it by using a system. The second thing is, are there 2 or more equations or conditions to be satisfied, right? Like you might have a problem that asks you about a certain number of total dollars together from two accounts, and then you might have another thing in the equation where it says that this account earns this interest, this other account earns this other amount of interest, and so we might have to have two equations, one that talks about the total number of dollars and the other that talks about the total number of interest that you accrue, okay? That's just one example. We're going to notice a couple of different examples here as we move on here, and let's go ahead and take care of that, right? So example number 5, it says clearance sale. I'll let you go ahead and pause the screen and read through the problem here. But let's go ahead and give this one a solve, right? So one of the first things that I always like to do, just so I know throughout the problem, is I like to go through and define some variables. So if you actually went through and read the problem, it asks you how many jackets were sold before noon and how many were sold after noon, right? So those are the two things that we don't know. I always encourage you to read the very last sentence. What is the question? The thing that they're asking you for, that's what you should let X and Y be equal to, right? So if I zoom back out here, we're going to do that. We're going to say how many jackets were sold before noon. We're going to let that be X, and then how many were sold after noon, we're going to let that be Y, okay? So if we do that and we use X and Y throughout the problem, we're always going to know what those equal, okay? So if you read through the problem, you'll notice that one of the first things that it says in the very first sentence, it says they need to get rid of 214 winter jackets, okay? And so if we take the amount of jackets that was sold before noon and we add that to the number of jackets that was sold after noon, that should equal the total number of jackets, which is 214, right? So my first equation here talks about the total number of jackets that were sold. All right, now we need to get another equation, and you'll notice that the other thing that this word problem talked about was money, okay? So we're talking about the total money here as we write our second equation, okay? And so whenever we do that, we were told that before noon, it was $31.95, so that'll be $31.95 for each of those jackets that were sold before noon, and then the price dropped down to $18.95 after noon. Okay, so it's going to be $18.95 for each one of those jackets that were sold after noon, so we'll say $18.95Y, and that is going to equal the total amount of money. If you go up and read, it says the total receipts for the clearance sale were $5,108.30. Okay, and so that's one of the things that makes these word problems a little bit tricky, is that you're going to have to go through and model the situation with a system yourself, okay? And again, you now are free to go ahead and solve this using whatever method you choose. I might encourage you that you stick with elimination here because it would be easy to do, right? We just need to go ahead and get the coefficients of one of my variable columns to match up. And again, you could do either one. I think we're going to go ahead and do here the x's. So let's go ahead and multiply everything times 31.95. And again, we're distributing that to everything. So that way we're just going to write that equation right underneath here. So that'll be 31.95x. Again, the whole point of doing that was so that the coefficients of my x's matched up, and then that would be plus 31.95y, and that is going to be equal to 214 times 31.95, and I'll do the math on that for you just to save time. That'll be $6,837.30, okay? And so I just lined up both of my equations here. I'm nice and lined up, and I'm ready to go. I'm going to go ahead and subtract these equations, and that is going to eliminate my x column, and we're just going to go ahead and do all the other columns here and get our y solved for. So if you were to go ahead and do that, you would be getting negative 13y in your y column, and then for your constants, you're going to be getting negative 1,729. Okay, and then in order to go ahead and solve this for y, of course, we're just going to go ahead and divide on both sides by negative 13, in which case you should end up with the following value for y. That will be 133. And again, just interpreting that in the context of the problem, y was the number of jackets that we sold after noon. So I'll say here that is the number of jackets that we sold after noon there, right? So 133, okay? In order to get the number of jackets that we sold before noon, we would just have to reach for one of our previous equations and plug in 133 for y and then solve for x. I think the easiest equation to plug back into would be this original equation that talks about the number of jackets, of course. So if we were to go ahead and use that equation again, so x plus y, which was 133, that is equal to the total amount, which is 214. If you do the math on this and subtract your 133 from both sides, you're going to get, of course, x is equal to 81. Okay, so that'll be 81 jackets that were sold before noon. Okay, and so here in this problem, I'll just go ahead and box these results. Again, we were just looking for the numbers of jackets in this problem. So again, that's pretty good. So again, the number one thing that you need to keep in mind is what are the unknowns in the problem. oftentimes that's going to be found in the actual statement of the question, right? So that is oftentimes the very last sentence. It's the sentence, of course, with the question mark, so read that one over. That'll tell you what to let x and y be so that if you solve the problem, you're going to be answering the question. I've done the next example for you here. This one talks about investing a total amount of money, so I would encourage you to go ahead and pause the video and give this one a read through. Again, you'll notice that I've modeled my two equations. That's over here, right? So one of the equation talks about the total amount of money. The other talks about the total amount of interest. So again, maybe pause the video, read through that one, and then we'll take care of the next one together. All right, so example 7, this will be the last one that we do, and this one is going to involve a little bit of geometry. So it says here, find the dimensions of a rectangle where the perimeter is 42 inches and the width is 3/4 of the length, okay? And so if we have a rectangle, which it's not required to solve the problem, but oftentimes it's nice to have a picture. There's a quick rectangle, right? We know that a rectangle has a length and a width, and we were told that if we were to go ahead and add the two lengths and add the two widths, all four sides of the rectangle, that would be 42 inches, right? So there's a little bit of a formula from geometry class that you may remember. 2 copies of the length plus 2 copies of the width is going to be equal to the entire perimeter. So that'll be one of our equations here in this problem. Let's just go ahead and simply plug in your 42, and then here is one of the equations in our system right here, okay? So that's pretty good. The other equation in our system is going to be this right here, this little verbal description where it says the width is 3/4 of the length. If you were to go ahead and translate that into English, the width, of course that's W, is, of course that's our equal sign, and then 3/4 of the length, that'll simply be the fraction 3/4 times the length. Okay, so W is equal to 3/4 times the length. Okay, and that's the other equation in our system. And this is pretty much already ready to go for substitution, because all I'm going to have to do is go to my perimeter equation, and wherever I see a W, I'm going to go ahead and take it out and replace it with 3/4 of L. Well, I see a W right here, and so what I'm going to do is I'm going to go ahead and do some substitution here. So 42 is equal to 2 times the length plus 2 times the width, where the width we were just told is simply 3/4 of the length. Okay, so if you do the math on that and simplify a little bit, that's going to be 2 times the length plus, that's going to be 3/2 the length. And if you were to go ahead and combine those together, that would give you, I believe, 7/2 of the length. Again, I'm just taking 2 plus 3/2. 2 you could write as 4/2, so 4/2 plus 3/2 makes 7/2. Okay, and of course that's equal to 42. And this is just one way to solve the problem, by the way. You could solve this with elimination. You could even solve this with graphing, right? You can graph these both by hand or by using the TI-84. You probably just want to go ahead and call the length y and call the width x in that case if you're trying to do that. But here we'll just finish this up. I'm trying to get rid of that fraction of 7/2 in front of L, and I could do that really easily by just multiplying the entire equation times the reciprocal of that fraction, because on the right-hand side, 7/2 times 2/7, that just becomes 1, and 1 times L is simply just L. And now in the calculator, we just simply have to go ahead and take care of 42 times 2/7, and if you were to do that, that would, of course, be simply 12, okay? And so the length here, we'll say, is going to be 12 inches in this problem. And, of course, we need to now go ahead and figure out the width, which we have this whole other equation for. So the width is going to be equal to 3/4 of the length, which we just found to be 12. And if you do the math on that, of course, that is going to give you 9 inches, okay? So the length is 12 inches on your rectangle. The width is 9 inches on your rectangle, okay? So again, one of the more difficult or challenging parts of this is what we did at the very beginning, which is read through the problem, model the situation on your own, and then give that a solve using any one of the methods that we've discussed in this video or in the previous one. So I hope this video has been helpful to you. Again, if you guys have any questions, feel free to get those answered by meeting me in the chat or just sending me a quick message. I'm always eager to answer whatever questions you have. Thank you very much for your attention, and I'll speak to you in the next one.